Welcome to this lecture. Myself, Dr.K.Sivanandam, Associate Professor from Department of ECE in MKCE College of Engineering. Today, we are going to discuss about behavior, logic and physical synthesis, which is majorly present in the chip design flow. First, system design description. So what it means, so how the three major subdivisions play a major role in the VLSI design. These things we're going to discuss now. Usually the systems are described in terms of three domains. One is behavioral domain, second one is structural domain, and third one is physical domain. So what is synthesis? The synthesis is a process of converting program code into a circuit. So program code means, so it may be Verilog code or VHDL code or system Verilog. So the programming level coding is need to convert into logical gate level design. So this process is called synthesis. So this is overall structure. It consists of behavioral, structural and physical. So in the behavioral, so we're going to define how the system behaves with respect to inputs, with respect to clock signal and with respect to the environmental conditions. So usually the environmental conditions means it become after fabrication of IC. So that things we not majorly focusing before the chip manufacture. So in this behavioral, so it consists of transfer functions, logic equations and resistor algorithms. So these kind of key parameters coming under in the behavioral domain. In the structural domain, so it consists of transistors, logic gates, flip-flops, then arithmetic and logical units, registers, hardware modules and processors. Now coming into the physical domain, so in the physical domain, so it consists of cells, macro cells, modules, chips, PCB boards. So here once we define our behavior of the module, so we need to convert the behavioral into structural, then we need to build structural into the physical, so that the logic synthesis and physical synthesis play a major role in the VLSI chip design. So system level design. So the system level design may follow two different approach. One is top down approach, another one is bottom up approach. So in the top down approach, the system design going to play major role. So in this system level design, using behavioral constructs is going to define. Next one is design validation is technology independent. So the technology independent we need to validate in the system level design. So next one is, so in this system level design, usually the programming code may play major role. So in this, the HDL2 model need to design. So next one key point is RTL is efficient for describing the data flow. So if coming into the data flow structure, so RTL is more efficient. In the verification, timing verifications is difficult unless the structural logic is defined. So the timing verification means that, so in a chip, it consists of large number of modules, say ALU, memory block, timer, clock, registers, etc. So based on the clock frequency, so all the synchronous circuits will operate. Say if one module is need to get data from two different modules, so while enabling the particular module or while going to start the functionality, all the input data should be present in the particular module. Then only that module will perform the record functionality based on the input from the various modules. So we need to ensure that the timing analysis in the design process. So in the chip design, so large number of submodules is present. So each and every submodules need to satisfy the timing. So that is most important in the VLSI design. So next one is logic design. In the logic design, basic functionality, timing and area conception of the design need to give as a library file. So from the library file, so if suppose we are going to use a CAD tool, so that CAD tool take the reference as from the library, accordingly it will give the result. So the result means it may be three parameters majorly we are going to analyze. One is timing analysis, another one is area analysis and functionality. Then another one parameter is power analysis. So these are all major category to enhance the performance of the chip. So in this logical design, so we need to minimize the number of logic gates. So if number of logic gates minimized during the design process, proportionally the area will reduce, and if number of logic gates reduced, the power consumed by the logic gates also reduced. Then the complexity which is present in the design also will reduce. So once the complexity is reduced, the routing, placement, complexity also are reduced. So the very first and foremost is, as much as we need to reduce the number of logic gates. So next one is fan out and fan in reduction. So this is another something which is present in the logic design. So next, what is logic synthesis? So say in the given example, the finite state machine functionality of x, y, z, del and lambda, where x is input, y is output, z internal stage, delta output function, lambda next state function. So this is constraint which is going to implement in the digital circuit. So the synthesis means, so we need to convert this functionality into gate level logic circuit. So this is state machine functionality. So the state machine functionality need to convert into logic gate level. So the logic gate level means it may consist of flip-flop logic gates like NAND gate, NOR gate, etc. So the synthesis play a major role which is going to implement or which is going to construct as a chip. For example, if the particular functionality is not able to convert into logic gate, definitely we can't able to implement the particular function. So it means that we can't able to convert the idea into the hardware. So synthesis, so our idea coming into reality. Objective function for synthesis. So one is minimize area. So minimize area, it means count. As I say earlier, the logic gate counts or cell count or register count or some modules may be merged with some other module. So as a goal, we need to minimize the overall area of the particular design. So next one, obviously we need to minimize the power. The power minimization depends on various parameters. While coming into the picture, so it depends on number of logic gates, it depends on supply voltage, it depends on switching activity. So here we majorly focusing the switching activities of individual gates. If the particular portion of module is not required for the actively to function for the particular time period, we need to deactivate the particular block so that the power consumption for the particular block should be disabled. So the proportionally the power consumption will minimize. Next thing, we need to maximize the performance of the design or entire system. So in terms of maximal clock frequency of synchronous systems, so we need to increase the clock frequency. Blindly we can't able to increase the clock frequency, so it need to validate in each and every block which is present in the entire system with the timing analysis. If the timing analysis failed, definitely we can't maximize the frequency further. So we need to step down the frequency. Again we need to validate the timing analysis. Once the timing analysis is perfect, so we need to fix the particular frequency as maximum operating frequency of the processor. So in the market, so while considering the specification of the devices or processor, definitely the operating frequency is given by the manufacturer, so it proportionally indicates the speed of the system. Then usually in the design flow, we not only considering only the area or only the power. So we are going to consider all the parameters together. As a whole, we need to increase the system performance in terms of computation, in terms of power, in terms of area. Next, these are all constraints present in the synthesis. First one is implementation style. So we need to pick the constraints from the customer. So it may be two-level implementations like PLA or CAM, or multi-level logic, or FPGA. So initially we need to take into account the constraints given by the customer. So the customer, it means that, so those who are all going to give a task to us to design particular system. Next one's performance requirements. So the customer will give the minimum clock speed for the particular design, and latency throughput also may mentioned in the constraints. So why the minimum clock frequency we need to meet out? So the as a whole or entire system, so they will constrain the design specifications in for timing based applications. So in such kind of applications we need to take a minimum clock frequency. Next one is cell library. So various kind of library cell is available. We need to pick the suitable library files. Sometimes the library files requirements or constraints also will given by the customers. So why we need to learn about the logic synthesis? So logic synthesis is the core of the today's CAD flow for IC and system design. So such kind of courses cover algorithms that are used in the broad range of CAD tools. It also supports the optimization techniques which is available in the embedded software. For example, this is basic for functional verification techniques. Then second thing is, most algorithms are computationally hard. While covering algorithms and flow are good example for approaching hard algorithm based problems. So next type is structural layout synthesis. So majorly it consists floor planning. So floor planning is nothing but it is the exercise of arranging the blocks of layout within the chip to minimize the area or maximize the speed. So for example, in civil construction, they will basically give a land area. So if say the land area is 40 cross 60 feet, so in that is available space only we can able to construct our building based on our requirements. Similarly, in the chip design, the die area or the chip area may be fixed as a maximum size. So as a design engineers, we need to fit in all the modules within the area. So we can able to swap the modules within the area. It means that in the civil construction, so that is available area. So the customer requirement is, say, one kitchen, one hall, one dining hall, one bedroom. So this is requirement from the customer, but the freedom is given for us is from the customer. We can swap the halls for our convenient. Similarly, in the VLSI design, we can able to swap the modules to maximize the performance based on the requirements. So that such kind of freedom is available in the design process. But sometimes in that freedom also blocked. Blocked, it means in the module, if the timer module is present in our design, means sometimes the customers may say the timer should be in the corner place. It means we need to fix the timer in the corner location itself. That is basic constraints given by the customers. So such kind of design, we no need to consider the timer. So while swapping the blocks, we need to eliminate the timer in the swapping process. So in this example, there is a 4 blocks A, B, C, D. So all the blocks we can able to swap within the locations, within the fixed area. While swapping the blocks, the connectivity path within the blocks may change. Number of connectivity may change, or the length of the connectivity may change. So accordingly, to minimize the connectivity, we need to analyze the number of cut set, which is going to play a major role in the partition. So during the partition itself, we need to analyze the length of the wire connectivity and cut set. Cut set means how many lines interconnect between the partition. So next, placement and routing. So placement and routing play a major role in the design flow, because based on the placement only the area consumption going to minimize. So placement means we are going to fix the each and every module in the given dimension. So in the civil constructions, we are going to fix the each and every block. Block indicates like hall, kitchen, bedroom, dining hall. So in this, we are going to fix each and every block in the allotted place. So routing means, so we need to connect all the blocks based on our functionality. So in the civil constructions, the power line is, we are going to taken from the service providers, like say EB board. From that we are going to give connectivity for each and every rooms. So in that connectivity, so we need to find out the shortest path. So why we need to find out the shortest path? We need to connect all the devices in the all the rooms. While during the routing, so we need to find the shortest place. We need to maximize the length of the required length of the cost. So cost means, so we need to reduce the wire cost, we need to reduce the wire length. Similarly in the routing which is present in the chip, we need to reduce the complexity which is present in the routing connectivity. So here this is a simple example. The channel routing is common path to take care of all the wire connections. Then individual logic gates, registers are placed accordingly. So this is a design flow of integrated system. So first one is system level, second one is register transfer level, then followed by gate level, transistor level, layout level and mask level. In the system level, abstract algorithm description is given. So it is higher level language, for example C programming language. So it means any kind of functionality we are going to use higher level languages based on the input. So based on the input during this execution, it gives the respective output. In the RTL level, so we are going to take care of physical properties. So physical properties means like registers, flip-flops, wires. So these are all physical properties. During the programming language, programming level itself, we're going to take care of this kind of models. So this is present in the RTL level. So RTL means register transfer logic level. Next one is gate level. So in this, so we are going to consider exact logic gates which is going to fulfill the Boolean functions. So next, transistor level. In this, the transistor level, exactly we are going to give the physical properties of the individual transistor. How much supply voltage we need to provide, then what is the capacitance and resistance of the transistor. So this is very narrow level. So this narrow level we can able to fix based on the available library files. Next, layout level. So in this level, so again further you're going to in depth. It means that, so which kind of wire connections, which kind of diffusions, which kind of metals, which kind of polysilicons we are going to utilize to construct the chip. So in this lecture we discussed the basic fundamentals of synthesis. Thank you all.